Alright, welcome back to another Java Basics tutorial, and today we're on episode 2. We're going to start out by learning some basic loops, logic, and about variables. These are just, may sound like a lot, but these are just some of the basic parts of Java that you just need to know, and you'll get them pretty fast. So first, let's start with variables. The first type of variable we're going to talk about are variables that carry whole numbers. So this is going to be int, long, short, and byte. So what's the difference between these? Int is the one you're just going to use the most common, just because it's easiest to type, and it makes the most sense. Int is like the best compromise between these, of like being able to be small and have a small storage impact while carrying a decent amount of data. So with that said, int would be that. It could be any number, negative or positive, but long can hold numbers a lot bigger than int. Int, let's say, only holds this amount of numbers. Now I'm just guessing, but long could hold a lot more. Now short holds less than int. Let's say it holds about that amount, and then byte holds even less than short. So you'll probably just end up using int or long, and you won't really use these unless you're really looking to optimize your program. So now that we have all of those down, let's get on to numbers that aren't whole. So that's going to be double and float. So it's kind of the same thing here. Double could say store that much, and there can also be a whole number in front of here. And float could maybe store like that much. So now what's the difference? So this means that double is more precise. So let's say I have like a problem where the answer might be this on double, but because float is less, it might be this. But that really shouldn't matter unless you're doing really precise calculations. So you can use float or double, it doesn't really matter. Now, we're on to our odd ones. This will be char and Boolean. Char stores a single character, so you can either write a char like this, or you can write a char like this. This one is based off of the ASCII chart, so its number is corresponding to the ASCII chart. So it's like what number goes with what letter. So let's just say this 32 goes with A. It'd be like 31 equals 9, 32 equals capital A, 33 equals capital B, and it goes through these for all the letters and characters. And that's just to store a single character. Now what's Boolean? Boolean would be true or false. So I have Boolean false, Boolean true. Of course, you also don't write any of these. You would have a variable name. Now, so you need a variable name for all these. So now, why do you need a Boolean? Boolean is good for like expressions. If I want to test, let's say I have a function, we'll call it for that for right now. A function that gets me x if x times y minus 32 equals max score. Now this wouldn't be how you would write it at all, but that's okay for right now. And this would return a Boolean either true or false, and then we could use that with logic to determine our next thing. Alright, so now that we really understand pretty much all the basics of these, let's get on to logic. So let's set up a program here. Public class video 2 public static void name. So now we added brackets, and let's show you what logic is. Logic is ifs and elses for the most part. So what can I do with logic? So let's say I have a variable int x equals 0. I have a variable int y equals 1. And I want to check if these two are equal. So I would say if x equals y. And you have to have two equal signs. One equal is assigning a variable, two is checking for equality. And then I wanted to say system dot out dot println not equal. But this isn't the only one we do. If we replace that first equal sign with an exclamation point, we can check to see if they're not equal. So then we would. So for this one we would say equal, and this one we would say not equal. Now this one we're checking to see if x is less than y. This one x is greater than y. This one we're checking to see if x is less than or equal to y. Or x is greater than or equal to y. So now let's say I have a second variable, and z equals 2. And I want to check if x is greater than y and greater than z. Now I could have two if statements, but I could also do if y is greater than, if x is greater than y and x is greater than z. I want to print out x is the largest. Now what if I want to say, see if x is greater than y or greater than z, so it doesn't matter if it's greater than both. Well, you're going to use two straight lines. So that's an or, that's an and. Now I want to check this, so let's run the program. So now let's say we want to check if x is greater than y or greater than z. So this time it should do nothing. Oops. There we go. And as you can see, it did nothing. But now, if I change x to 2, so it's only greater than y, because this is only x is greater than z. So 2 is equal to 2, so it's not greater than z. Now if I run this, that's annoying. It's going to say x is the largest, which just means x is larger, because it didn't change this. Now, let's say I want to have the user enter their sprint time. So I'm going to need to get a scanner. I'm going to need to import the scanner. And now I need to create a scanner. So scanner scan equals new scanner. And system.in. Now we're going to create a variable, or now we're going to create a loop. So let's talk about loops. Loops will run for a certain amount of time, or will run until you make them stop. There's a couple different types, but for now we're just going to start off with the while loop. So with the while loop, you're going to have something in here. So you could have, for booleans, you can have, let's say my boolean is named x, so x equals true. While x is true, you don't need to put anything in there. You don't need to put while x equals true, because that's already implied by the Java. But if I also put a not sign that says while x is false, so you don't have to type while x equals false. So it's pretty fast. But let's say I don't really care about that, and I want to see, let's make a program about running, test the running speed. So we're going to have a string. A string allows us to put a string of words. Actually, now we want a double. Entered time equals 0. Actually, we'll say enter time equals 1. double best time equals 0. Double worst time equals 0, and then we'll just do that for right now. So now we're going to say while entered time is greater than 0. This means that whenever they enter 0, the program ends. So let's go into some instructions. Need to capitalize that, system that out. Let's retry that one more time. Entire times in seconds. Type 0 when you are done. Now we're going to have entered time equals scan dot next. Oh wait, no. Scan dot next end. If, so we can use our conditional. If entered time is greater than, actually we're gonna set worst time to 0. We need this to run one time actually outside. And we're gonna go best time equals entered time worst time equals entered time. Wait, what am I doing there? And now line enter your system.out.line. Enter your next time. Type 0 to end. So now we're going to want to see if entered time is greater than best time. We want to set best time to equal entered time. And if it is, then we have a new best time. Now, if entered time is less than the worst time, we're going to want to set worst time to enter time. Alright, and that should be all we need. And at the very end, we're going to print out the best and the worst time. Print line best time equals, and then we're going to add our best time. And then we'll just do this. That means new line. /n means new line, /t means tab, // allows you to just put a slash, and there are a few others. /n worst time equals, and now we're going to add our worst time. So let's see, does it work? Oh, just missed one. Oh, I misspelled that. Alright, so let's run it. Let's see how it is. Enter time in seconds. Type 0 when you're done. So let's say I ran a sprint in 2 minutes. And then I ran it in... Alright, I need to fix something after this. Because these reversed. The higher the number, the lower your time. So let's say then I went 90. Then I went... Let's say I got tired. I went 140. Maybe I tripped again. So I went all the way up to 240. And then I took a break and I got 80. Now I'm done. So my best time was that. And my worst time was that. But let me fix that. See, because it's still accepting 0 as my worst time. So we're going to say if entered time does not equal 0. So this will prevent our worst time from changing to 0, or our best time to changing from 0 after I fix the program. So if it's not 0, then it's going to run. And we also need to flip these signs, because your best time is going to be the lowest one, and your worst time is going to be the highest one. So if we rerun this, let's redo it. So let's say I got 120. Oh, mistyped. And of course, you can make your program so it'll stop that exception from running and it'll keep running. Let's say I ran it 59, 85, 78, 240, let's say 60. Alright, now I'm done entering my times. And now my best time was 59 seconds, my worst time was 240. Of course, I never even showed off the fact that you can put decimals in here. So let's say 240.1.22. Oh, what did I mess up? Oh, did I put enter time as an int? Ah, I did scan.nextInts instead of scan.nextDouble. So now if we run it, and we grab that actually. So let's see, 149.5, 130.8, 60.23, 59, 240, 89.5346, 0. So our worst time here was, the best time was 59, and our worst time was 240. So now, we could also, next time, I think we'll upgrade this program a little bit. We'll add a method to get the average, but I'll also show you an array. An array allows you to store multiple of these numbers. And I guess I can show you a for loop with that too. But that's pretty much it for this episode. Thanks for watching, and I hope to see you in the next one.